Okay, the bottom line I was getting to is that physical and biological components, the parts of an organism's environment, change. The organism changes, the environment changes, and so being well adapted is a moving target because things are changing. So it isn't as though something evolves and then it's fixed, it's done, it never changes again. If something is incapable of changing, it's at greater risk of becoming extinct if the environment then proceeds to change. Okay, so what were the other two things we've been talking about? Genetic drift, gene flow. Both of these can increase the frequency of alleles that improve this match, this adaptation to the environment, but neither one is consistent, right? Because we're talking about things that are relatively random. So it may increase the frequency of beneficial alleles, it may decrease the frequency of beneficial alleles. So out of the three, natural selection is the only evolutionary mechanism that consistently leads to adaptive evolution, that consistently leads to organisms having a better fit to their environment. Now, there's one specific form of natural selection as we move on through the end of these slides, and that's sexual selection. Sexual selection is a specific type of natural selection, and it's for mating success. So you may have a great fit to survive in an environment, but if you're going to leave genes to the next population, you've got to mate. Okay, and this again, we're talking about organisms that reproduce sexually. Now, one of the consequences of sexual selection is something called sexual dimorphism, marked differences between the sexes in secondary sexual characteristics. So dimorph, two forms. So, such as our own species, where we have a very defined male and female form. Or in the case of these peacocks, okay, the peahen, the female is to the left, the male, the peacock, is to the right. Now he's got some pretty impressive looks here, right? He's got a lot of colors, got this huge tail, and that's the sort of thing that for that species really wows the girls. However, you may have something of a trade-off, because let's say you've got the colors and the tail that wows the girls, but if you can't run to get into flight fast enough that you don't avoid being eaten by tigers, okay, you've got a trade-off. So sexual selection sometimes, in being able to attract females or males, depending on how the species works, there may be disadvantages for overall survival. So it's interesting that we see this tension frequently, that an organism is sort of fighting the tensions of survival versus ideal sexual selection features. Now, a couple of terms here. Intra always means within. Okay, so intrasexual selection is competition among individuals of one sex, and this is commonly males, for mates of the opposite sex. Okay, so when you see things like elk fighting by tangling their antlers and battling with each other, or males trying to drive other males out of a territory, many things like you may have seen footage of seals, where you get this huge male driving off the other males from a physical territory and trying to corral all the females. Okay, so this is intrasexual. This is competition among individuals of one sex. The next is called intersexual selection, so often sometimes referred to as mate choice. And this occurs when individuals of one sex, usually the females, are choosy in selecting their mates, because in many species the female has the greater physical contribution. Even if it's something like an organism that lays eggs, the female has to use resources to construct the eggs, to lay the eggs, and in many species to protect the eggs. So frequently mate choice is the sex that has the greater investment being choosy about the other, choosing the mates. And again, like we just saw with the peacocks, male showiness that is driven by mate choice can increase the male's chances of attracting a female, but decrease his chances of survival. So there's this interesting tension again, like I mentioned earlier. Now, how do these female preferences evolve? How does mate choice work? One hypothesis is called the good genes hypothesis, and it suggests that if a trait is related to male health, both that male trait and female preference for that trait should be selected for. And they give you an example in this book of these tree frogs. Now there's the female tree frogs, and there are two populations of males. LC refers to long calling, SC refers to short calling. So they were able to do is observe, okay, the males as they called. They would collect males, okay, and determine what their, if you will, DNA fingerprint was, and determine, okay, which of the two calling types fathered the most offspring, and then look at the fitness of these half-sibling offspring. So it was a way of seeing, okay, who fathered the most offspring, and did those offspring have greater fitness, have a higher rate of survival and reproduction. And you see the results here in this table, okay, that when you see NSD, that means no significant difference. LC meant that the offspring of the long calling males were superior to the offspring of the short calling males.